Welcome back to Manish Kumar channel. So today we are going to talk about roots of complex numbers and with some examples, right? So as we have already seen exponential form of a complex number in the previous video, so now we are going to know how to find the nth roots of the given complex number. So z can be written as r e power I theta, and then in that case nth root means z power 1 by n, and it's going to be the same r e power I theta to the power 1 by n, and then in the general form we can write r to the power 1 by n e power I theta plus 2k pi divided by n, right? So we list all the roots in wk, where k is in between 0 to n minus 1. So there are total n roots, right? So let us see a very quick example. Find cube roots of minus 8i. Okay. So first we find the r magnitude, and then we find the argument, and then we write in the form of you know exponential form, right? Which can be obtained for this value. So this is my polar form, okay? And then the roots wk is going to be again in the general form. We are going to write, okay? We're going to write in the general form, and then where k equal to 0, 1, and 2. So in that case, the first root is root 3 minus 1. So this is w0, and this is w1, and this is w2, right? So these all are the three roots we can easily obtain after plugging the k equal to 0, k equal to 1, and k equal to 2 in this expression. Okay. Similarly, we can also find the fourth roots of 16. So again, the same structure we have to convert into the polar form, and then fourth root using the same formula wk, k equal to 0, 1, 2, and 3. So all the explicit values of the roots are 2i, minus 2i, 2, minus 2. You got it. Of the radius, this is the radius 2 and circle. So all the roots lie on the circumference of the circle. Okay. Similarly, we can find the roots of unity, right? The nth roots of unity are the solution to this equation, right? And then wk, as we have obtained before. So here wk is e power I 2k pi divided by n, and k equal to 0 to n minus 1. There are total n roots, right? So for instance, if n equal to 6, then the sixth root of unity are wk e power 2k pi divided by, if we replace n by 6, and then k runs from 0, 1, 2, 3, 4, 5, then you can see that all roots are lying on the circumference of the circle, right? So let us talk about one more interesting point here. If you see here in this example, right? So if I'm talking about the same example, let us talk about this example in a very simplest manner. So if I'm talking about the example, so suppose I have the W plane, suppose I have the Z plane, right? So this is Z plane, okay? And suppose this is W plane, okay? So what had happened here is, if I'm rotating this 0 to 2 pi, Okay, 0 to 2 pi. What effect had happened here is then theta lies between 0 to 2 pi, right? Then correspondingly this, if you see here, divided by 3. So what had happened here is this angle will lies here, 0 to theta by 3. So 2 pi by 3, right? And if we move theta, so theta less than 2 pi, 4 pi, what had happened here is this is going to be 2 pi by 3 theta, and this is 4 pi by 3. Okay, and if theta lies between 6 pi to 4 pi, then what it will in the W plane? It will be 4 pi by 3 less than theta less than 6 pi by 3. 6 pi by 3 means 2 pi. So you see here the important part, this is in Z plane. These all are the bracket quantity is in Z plane, right? So you can see here Z plane. So this is first rotation, right? And this is second rotation. Second rotation means I'm going to start from rotating here and going to stop here, right? And this is third rotation, third rotation. Okay, so in third rotation means I'm going to start here, again rotate here, right? So what had happened here in this plane, we are going to move only, if you see, we are going to move 0 to 2 pi by 3, right? And then second rotation, when you do second rotation, I'll be moving only this portion, right? And in the third rotation, I'll be moving till here. So what had happened is the function is multiple valued, right? The given function is multiple valued, right? Because you are going to find the cube root of this complex number. Cube root of this complex number, I mean minus 8i to the power 1 by 3 is going to be my E of z, right? So F is a map from, this is Z plane to W plane. So F is a map which is mapping Z to that W, right? So the reason here is this is multiple valued function. And I already discussed in the previous video, if you have a multiple valued function, then you have to make it into the single valued. So now we are making into the single valued, right? So one rotation, we are going to get a one. So this is going to be one sheet, and this is going to be another sheet, right? If we are representing by this symbol, and this is going to be another sheet. So basically, we are having three Riemann sheets, right? And this sheet, if you look at this blue line, each blue line are separating the functions, right? Because function has different value in this sheet and the different value in the other sheet, right? So this line is called as the branch line, right? And where they all are meeting together is that origin point. If you see, they all are meeting together is going to be the, you know, a branch point. This point 0 is branch point. Branch point is z equal to 0, right? So this we will discuss later when we talk about the singularities. So we will see how the branch point and branch cut will be discussed. But for time being, this cube root of unity, you can see we have three Riemann sheets, right? In each sheet, the function is single valued. Now this function is single valued, and this is also single valued, and this is also single valued. So in each sheet, the function is now single valued. This is our job to, to solve the complex, while solving the complex analysis, we always break down the multiple valued function into the single valued function. This is the whole idea, right?